Good morning. So if you're watching this video, then I'm assuming today's date is uh, Thursday, October the 13th. Okay, which means your assignments have been submitted. Um, I don't know if I have them marked yet. We'll see. My goal is to have them marked. But anyway, so today is Thursday, October the 13th. Now you'll be starting Unit 3. So the first lesson, reciprocal functions. So in front of you at this point, it looks like a pretty daunting booklet, but it's the same thing repeated to get you used to what a reciprocal function is. There is no homework, so treat this booklet as your homework. Try to get it done for Monday, okay? Because we will be moving ahead on Monday, because I am spanning this over 2 days, okay? And of course, as always, if you have any questions, feel free to email me and I can clarify things for you. Okay, so let's go. Unit 3, Day 1, reciprocal functions. So the goal is, by the end of today, you'll be able to sketch, not by the end of today, by the end of tomorrow, which is Friday, you will be able to sketch any reciprocal function. What is a reciprocal function? Let's look over to Desmos. So first off, here's a linear function. Okay, it's a line. Y equals x plus 1. Y equals mx plus b, right? So a reciprocal function is simply this. I'm going to take this, okay, and put it into a fraction. So it's going to be 1 over x plus 1. Okay, so a reciprocal function is essentially putting this into a fraction. If I were to use a quadratic, for example, which is our second example, so x plus 1 squared minus 4, let's use that. Y equals x plus 1 squared minus 4. So let me get rid of these two. So here's a parabola, right? So what's the reciprocal function of this quadratic? Just 1 over copy, paste. So the purple is our reciprocal function. Okay. Now, how do we get from our original to our reciprocal? Okay. How do we get from our original to our reciprocal? Well, let's take a look. Let's see if we notice any patterns. So a reciprocal function is simply 1 over fx. Okay. If fx is our original, 1 over fx is our reciprocal. This is not to be confused with inverses. Okay, inverses is something we'll talk about. Something that you have talked about in grade 11. An inverse is essentially, if I were to write out y equals 2x plus 1, an inverse would be swapping x and y. Okay, so you get x is equal to 2y plus 1 and rearrange for y. So then move the 1 over, equals to 2y, divide both sides by 2. So this would be the inverse of y equals 2x plus 1. An inverse is just a function that is reflected on the y equals to x line. Okay, and I wanted to make this clear because the notation for an inverse is f negative 1x. Okay? That is not the same as a reciprocal. If none of that made any sense to you, it's okay. Just know that a reciprocal function is not an inverse. And if you don't know what an inverse is, we'll talk about it at a later date. Like I said, not an inverse. Okay, so these two are not the same. All right, let's take a look at these two. A linear function and its reciprocal, a quadratic function and its reciprocal. So our job is to try to see if we notice any patterns. So the first thing I notice is if we look at the linear function y equals x plus 1, we do see that it has an x-intercept at negative 1, right? Now we also notice that for our reciprocal, which is our red graph, we have this dotted line here. Now this dotted line is what we call, this vertical dotted line is called a vertical, maybe I should use red so you know I'm talking about the reciprocal. this is what we call vertical asymptote. Okay? That's what we call a vertical asymptote. Now, what exactly is a vertical asymptote? Well, if I hop in over here, so x equals to negative 1. Let's make this line dotted. Okay, so a vertical asymptote is essentially a vertical line that our reciprocal graph, which is our blue one, will never ever touch. Now, if I scroll up, it looks like it does touch, but it gets really close, but never actually touches. Okay? Never actually touches. Now, the vertical asymptote at x equals to negative 1 also coincides with the x-intercept of the original. Okay, so there is a vertical asymptote on the reciprocal function. Let me switch over to blue, where there is a x-intercept on the original function. Okay, let's see if that makes sense. So this is saying that there is a vertical asymptote, so a line that our reciprocal function would never touch, where there is an x-intercept on the original function. Well, let's think about this logically for a second. Y equals x plus 1, okay? There is an x-intercept at negative 1 because if x equals to negative 1, we have y equals to x plus 1, y equals to negative 1 plus 1, y equals to 0, right? And sure enough, this point right here is at negative 1 and 0. Now, if y equals to 0, well, what happens to our reciprocal? Well, if this goes underneath, then that means we will have, for the reciprocal, y equals to 1 over x plus 1 equals to 1 over negative 1 plus 1 equals to 1 over 0. Can you divide by 0? You can't, right? Which is why our reciprocal function, our red graph here, will never touch that vertical asymptote, because what happens at negative 1 is you end up dividing by 0, which you can never have. You can never divide by 0, which is why we have a vertical asymptote. Okay, so this will always hold true. A vertical asymptote on the reciprocal function where there's an x-intercept on the original. Let's see if this is true for a quadratic and its reciprocal. Well, if you look at this quadratic function, you can see that there is an x-intercept here on the blue graph, x-intercept here on the blue graph. And sure enough, for our reciprocal function, you can see that there are two vertical lines, one at x minus 3 and one at x equals to 1, where our red graph will never touch. Okay? And this will be true for all functions and their reciprocals. What else do we notice between the reciprocal and the original? So let's take a look at just the left-hand side of the vertical asymptote for a second. Okay. Actually, no. Let's look at the horizontal asymptote for a second. Now, I said that there was a vertical asymptote at the x-intercept of the original. Now, a horizontal asymptote would be a horizontal line. A horizontal asymptote would be the horizontal line that our function never touches. Okay. Now, if I looked at this, it looks like it's approaching the x-axis, right? So it looks like it's approaching the x-axis. I'm going to make this black as well. Okay. But it never actually touches the x-axis. Okay. Now, why is that? Well, if you look at your reciprocal function, which is the red graph, and I want to solve for y equals to 0, because that would be the horizontal line, right? I would get 0 is equal to 1 over x plus 1. Is this solvable? Can I find an x such that 1 divided by some number will give me 0? No, it's impossible, okay? Which is why we have a horizontal asymptote at y equals to 0. The same thing would happen down here as well, okay? So you can see that if this is our reciprocal function, okay, and I want the horizontal line, that's where y equals to 0, I would get 0 is equal to 1 over x plus 1 squared minus 4. So again, 1 divided by some number to give me 0, not possible. So that again tells me there is a horizontal asymptote at y equals to 0. Okay. And there are vertical asymptotes here. So I'm just going to put VA for vertical asymptotes now at x equals to -3 and x equals to 1. All right, so that would be point number 2. I'm going to use green for that because they apply to both. There is always a horizontal asymptote at y equals to 0. Now I can hear some of you thinking already, can the horizontal asymptote be elsewhere instead of y equals to 0? What about y equals to 1 or y equals to 2? Yes, that is possible, but that's later on in this unit. Okay? But right now, just know there's a horizontal asymptote at y equals to 0, and that's it. Okay. Couple more patterns. What else do we notice? Now I'm just going to clean this up a little bit. Okay. Of course, if you want to see this again, just rewind the video or go back. Is it still called rewind? I don't know. Let's go back. Erase, 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 erase. Okay. What else do we notice? Well, if I look at we're just going to look at the right of this asymptote, okay? Look at this original function. This is increasing, isn't it? So the original was increasing. Well, let's look at our reciprocal. Is our reciprocal increasing? Nope. Our reciprocal is decreasing. Okay. Now let's look at our original. On the left-hand side. So if I look at this section, is this increasing? It still is, because you read these graphs like you read a book from left to right. Well, if that's increasing, well, let's look at our reciprocal. Is that decreasing? It sure is. It is certainly decreasing. Okay. Now let's see if the same applies down here. So if I look at the right-hand side of this x equals to 1 asymptote, I can see this is increasing. Now let's look at the red. Is the red increasing? Nope. The red is decreasing. Okay. So what can we say about a function and its reciprocal? Well, we can say the reciprocal increases where, let's switch to blue, the original decreases. And the opposite is true as well. The opposite is true as well. So meaning, if the reciprocal decreases, then the original will increase, okay? Again, I'm just going to check one more section here. So you can see this section of the graph, it's decreasing. Well, let's look at the red. Is the red increasing? It sure is. Now, again, think of this logically. Does this make sense? Well, this is the original, right? Well, if the original is increasing, right? And then our reciprocal is just 1 over y, okay? So if this is increasing and we're looking at the reciprocal, then that means this number, y itself was increasing. But what happens when you divide 1 by a very big number? Does this whole thing decrease? Well, let me just show you with a calculator. So let's say I have 1 over 2, okay? So 2 is our original function. So what happens if 2 increases? Well, let's make it 3. Our reciprocal will then be decreasing because now I get 1/3. So let's see if I make this 1 over 30. So you can see the bottom number, the denominator, is increasing, right? Which is our original. Then our reciprocal, which is 1 over 30, is decreasing even more. Okay. All right. Now, let's see. Those are the 3 main points. There are a couple more, but I think these are the most important ones to kind of get us started. If you notice any more, feel free to add them. I just don't want to overwhelm you, especially since I'm not there. But there are a couple more, like for example, the original and the reciprocal will always cross at x equals to, y equals to 1. Why is that? Think about it. But I'm not going to address that right now. Or you know what? I'm just going to write it down. Okay? So you can see here at 1, they will always intersect. And for now, I'm not going to go into the explanation. I'll go into it on Monday. For now, just take my word for it. Okay? So you can see at -1, so at 1, they are intersecting. At -1, they are also intersecting. Okay? Let's see over here. At x equals to 1, y equals to 1, not x. They're intersecting there. What about -1? They are intersecting there, they are intersecting there. Okay? So the reciprocal and original will always intersect at y equals to 1 or y equals to -1. Okay, so again on Monday I'll explain why that is. If you can figure it out, great. If not, just take my word for it right now. Okay, so let's go through a couple of these examples then. Ooh, the asymptotes. Okay, let me go through these asymptotes first, and then I will talk about some of the examples. So a vertical asymptote is a vertical line that the end behavior of your graph approaches but never touches. Let's say this is 2, and let's say this is my graph. Oh, sorry. Let's use 1 because I clearly used 1 in my example. Okay, so what does this mean? So it's a vertical line that the end behavior of a graph never touches. So if you look at what I wrote here as, just this top part. As x approaches 1, and this little negative sign means from the left, as x approaches 1 from the left, our function fx will approach infinity. Okay? So that is saying as x, or as our function approaches our asymptote at 1 from the left, our function would shoot straight up to infinity. What does this second one mean? The little plus sign means as x approaches from the right. So as x approaches 1 from the right, so down here you can see it's approaching from the right hand side, so this would be the right hand side, this would be the left hand side. As x approaches from the right hand side, approaches 1 from the left hand side, what happens to our function? It shoots straight down, or in other words, heads towards negative infinity. And that's what's happening there. Okay, so this is just the notation on how to show the end behaviors. And what about a horizontal asymptote? So same thing, I'm going to use the same graph, okay? So this first, what does this mean? So if we're looking at it horizontally, then we're looking to see what happens when x becomes very, very big. So I'm going to use yellow for this. So as x becomes very big, so out here, okay, fx approaches 0 from above. Well, this is not true. So I'm going to actually edit this because I want to use the same graph. So I'm going to change this to a minus sign. Okay, so what this means is this minus sign approaches from beneath 0, which does it? It sure does. If you look at our green graph, it approaches our asymptote, our horizontal asymptote, at 0 from underneath. Okay? Now let's take a look at this. As x approaches negative infinity, or in other words, as x becomes very, 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 very small, fx approaches 0, and again I'm going to change this to a plus, okay, which means approaches from above 0. Okay, so does that make sense? Well, as x becomes very, very small, which means it's shooting to negative infinity, then our function, sure enough, does approach 0, but from above 0. Okay? So that's how we would write the notation. Now this is going to take practice. You have today and tomorrow. We might even spend Monday just so I know for sure that we know what we're doing. Okay? So I'm going to go through 2 quick examples. Number 1. Here is a linear function. So the reciprocal function would simply be y equals to 1 over x minus 4. Just put this underneath. Done. Where is the vertical asymptote? Well, the vertical asymptote would be where the denominator equals to 0. So x minus 4 equals to 0. Solve for x. You get x is equal to 4. So I know there is a vertical asymptote at x equals to 4. I'm going to put VA. Let's use blue. Horizontal asymptote. So for these 2 lessons, or for this lesson, there is a horizontal asymptote at y equals to 0. Always. Horizontal asymptote. Now, I'm going to skip the domain and range for all of these, okay? Because I feel like that would be too much. I will revisit this on Monday. I'm going to come back to domain and range. Intercepts. What are the x-intercepts? Well, the x-intercepts of the reciprocal would be where y equals to 0, right? So let's look at x-intercept first. So x-intercept, you set y equals to 0. So what was our reciprocal function? Our reciprocal was 1, y equals x minus 4. If I set y equal to 0, 1 over x minus 4, is this possible? 1 divided by what number will give you 0? Not possible, so there are no x-intercepts. What about y-intercept? Well, if for the x-intercept you set y equals to 0, then for the y-intercept you set x equals to 0. excuse me. Then you get y equals to 0 minus 4, y equals to negative 1 over 4 is our y-intercept. Okay? So we have that. Now the end behavior for all of the asymptotes. Okay, so what are our what are our intercepts? So the first one is at x equals to 4, okay? So I know that there is a vertical asymptote at x equals to 4. What's my other one? Horizontal asymptote at y equals to 0. So we need to find the end behavior because we need to know if it's approaching these as it approaches it from the left or the right or above or beneath, whether it goes to infinity or negative infinity. Okay? So what was our original function or reciprocal? It was y equals to 1 over x minus 4. Okay. So how do we test these before we sketch them? Well, I know that there is a vertical asymptote at x equals to 4, which means that, now you don't need to sketch this, this is just for me to give you a visual, that at x equals to 4, which is right there, let's pretend that's 4, we need to know as it approaches from the left and from the right, whether, let's look at the left, does it approach it and go up like this, or does it do this and come down? Which one is it? Well, how do we test that? We do that by choosing numbers that are very close to 4. So I'm going to choose 3.999. Since I'm approaching from the left, then it should be a number less than 4, right? So then I simply plug it in and see what happens. Y equals to 1 over x minus 4 equals to 1 over 3.999 minus 4. And then let's see what kind of number I get. Do I get a very big number or do I get a very small number? 3.999 minus 4, negative 1,000. Pretty small number, so I'm going to, safe to say it's going to approach negative infinity. So how do I write that? As x approaches 4 from the left, okay, I can write y or fx. You know what? Fx is probably safer. Fx approaches negative infinity. Okay, which means now I know graphically that this is the correct choice and not the one above. Okay, now I need to know the right-hand side. So this was the left-hand side. Now let's check the right-hand side. Choose 4.0001, which is a number from the right. Okay, so I'm just going to choose a number from the right, and then I'll have y equals to 1 over 4.0001 minus 4. Now let's see if this is going to be a very big number or a very small number. That's a very big number, isn't it? Very, very big number. Okay, so what does that mean then? So now I know that as x approaches 4 from the right, our function will approach positive infinity. There we go. Okay. Now we do the same thing for a horizontal asymptote, but the only difference is it's instead of left-hand side and right-hand side, it's just going to be above or below. Okay, so I'm just going to choose. So if I'm approaching from above or below, okay, so y equals to 0 would be pretty much the x-axis, right? So I want to know if my function is going to approach from above 0 or below 0 on this side, and over here from above or below. Okay, so how do I do that? Well, I'm going to choose a very big x value. So let's say let's choose 10,000. Okay, so this would be on the right. So, because I want to know what happens when x becomes very big. Okay, so I'm going to choose 10,000. So I get y equals to 1 over 10,000, 1, 2, 3, minus 4, and see what value I get. So it's 1 over 10, 1, 2, 3, 1, not that it matters. So looking at that number, okay, scientific notation, it essentially means it's 0.0001, but the point being it's positive, right? 0.00001, okay? Since it's positive, then I know it's approaching from the top, okay? Because you can see this number is slightly above 1 instead of below 1. So how do I write that? As x approaches a very big number, then fx approaches 0 from above. Okay, now let's look on the other side. So this side right here. So now I'm going to choose a very small number. So let's go y equals to 1 over negative 10,000, 1, 2, 3, minus 4. Now equals, without even plugging this in, I know it's going to be a negative value since I chose negative 10,000. But like I mentioned earlier, it's not, the horizontal asymptote is not always going to be at 0. It could be another number. So get in the habit of doing what we're doing now. So we get a very small number, so 5 zeros. So this becomes negative 0.12345 which essentially means that this is going to be approaching from underneath. Okay, so this is as x approaches negative infinity, fx approaches 0 from underneath. Okay, now that we have all of this, we are now able to sketch our reciprocal. Okay, now I'm also going to skip increasing, decreasing intervals, and we're going to use everything here to sketch our reciprocal. So this is on the back page. So our job is to sketch y equals to 1 over x minus 4. So first off, the graph is a little hard to see, but there's 0 in the middle. Okay, so our first job is to find or sketch our vertical asymptote. Okay, so I'm going to find that at x equals to 4. 1, 2, 3, 4. Okay, and I'm going to draw a vertical asymptote there. In fact, I'm going to use a red highlighter so you can see it better. Meaning our graph will not cross this line. Okay, now there's also a horizontal asymptote at y equals to 0. So that is right here on the x-axis. Why is this being finicky? Okay, so there's our horizontal asymptote. Now, let's sketch the graph, and let's sketch the whole thing in purple. Oh, wait, intercepts, right. So let's use pink for the intercepts. So there's no x-intercept, but there is a y-intercept at negative 1/4. So negative 1/4, let's assume that all these values are 1. So this would be negative 1, negative 2, negative 3. This would be 1, 2, 3. Okay, so there's a y-intercept at negative 1/4, about right there. Y-intercept. Okay? Now, let's sketch the whole thing in purple. So how do I sketch it? Well, let's look at the end behavior first. Let's take care of this. So as x approaches 4 from the left, fx approaches negative infinity. So in other words, as x approaches 4 from the left, fx becomes very, very small. So as x approaches from the left, which is this way, okay, fx becomes very small, this way. So I know that the end behavior here would be heading down there. Okay, so that's one done. Now let's read the next end behavior. As x approaches 4 from the right, fx becomes very big. So as fx, or as x approaches our vertical asymptote from the right, fx becomes very big, so it shoots up. So I know my end behavior over here would be right there. Now let's read our horizontal. So as x becomes very, very big, fx approaches 0 from above. So as x becomes very, very big, so I'm heading this way now, it approaches from above the blue horizontal asymptote. Okay, now over here, last one, as x becomes negative infinity or approaches negative infinity, becomes a very small number, fx approaches 0 from underneath. So as x becomes very small, fx will approach from underneath. Now that we have all the arrows, we have the asymptotes, we have the y-intercept, I can sketch my reciprocal. So I know that it's going to be underneath, so I know it's going to head this way, it's going to cross at the y-intercept and head down, so that's a part of my graph. Now let's look to the right of my vertical asymptote. I know this is my end behavior, so I'm going to head down and essentially, well, that's brutal, essentially connect these, okay? And that is this half of the graph. This is actually a really bad drawing. I over-exaggerated the arrows just to show you what the end behavior is, but I want to make this a little bit smoother. There we go. It should approach my horizontal asymptote but not touch it. And this should also be a little bit smoother. So I'm just going to correct this right here. And we're done. That is your first reciprocal function. Okay, so I don't think it's realistic actually to cover the quadratic versions as well, although it's the same thing. Okay, quadratic function and its reciprocal is the exact same thing, but it's more work. So I'm going to save the quadratic for Monday, okay, and kind of wrap this up. So what I want you to do is only do the linear ones, only do the 1 over linears. So for example, that's a linear function, and then sketch it. Here's a quadratic, don't do that one. Okay, here's another linear, so you can do this one. That's a quadratic, so skip it. So there's just a couple linear ones there, and if you, after doing those 2 linear ones, you feel confident that you can tackle the quadratic, give it a shot, okay? All right. I'll see everybody on Monday. And again, please email me if you have any questions.